Hi, my name is John Brocka. I'm professor of history, religious studies, and philosophy here at Penn State. Welcome to my second virtual field trip. This is for the class, The Ethics of Climate Change. And in this field trip, I'm going to introduce you to Paul Moser, who is the Director of STEAM Services here at the University Park campus. Paul runs the East Campus power plant, you can see right behind me, as well as the West Campus power plant. And together these provide steam for over 200 buildings on campus. Not only that, through something called combined heat and power, they produce a lot of electricity for campus as well. What we want to understand today is what Penn State is doing to reduce its carbon footprint, and what are some of the real-world problems that we face as we try to change our energy makeup. What are some of the barriers? What are some of the possibilities? And who are the people who are making this happen?
Okay, so good morning. I'm Paul Moser, and I'm standing here this morning at the East Campus steam plant, which is behind you. It's one of two combined heat and power plants that the university owns and operates. Together they serve the campus more than 200 buildings, primarily with steam. The steam is used to heat the buildings. We're producing steam inside this plant. We deliver it to campus through pipes that are underground. Some of them are buried directly, some of them are in tunnels. We deliver that steam to a loop system, which is in core campus, a tunnel system. We deliver that steam to that loop, and from there we can serve each of the buildings around campus. In each of the buildings is a mechanical room. The steam meets a small heat exchanger, and it gives up its heat to the hot water, and that hot water is used to heat a building. And as I say, more than 200 buildings on campus we do that for. Once that steam has given up its heat to that hot water, it itself becomes condensate or liquid, and it is returned back to the plants, both here at East and at West. And then we recycle that energy. That water has been heated, it's been treated, so it's very valuable to us, so we have condensate coming back to each one of these plants. On a cold winter's day, we need both of these power plants to serve the entire university. We cannot operate, they are not redundant. In the summertime, really we're heating hot water primarily. There are some processes also that we are serving, but primarily we're heating hot water. In the winter time, it's the hot water, it's the heat for the buildings. Our steam load in the winter is more than 6 times higher than our steam load in the summer. At the same time that we're making steam, we're also making electricity. On a cold winter's day, we can make almost 8 megawatts of electricity here at East. We can make another 3 to 4 megawatts at West. That's somewhere around 11, 12 megawatts of power. The university on a hot summer day consumes more than 50 megawatts of power. So we're producing about 20% on a summer day. We're producing closer to 35 or 40% on a winter's day of electricity. And that combination of making electricity while you're producing steam and using the wasted heat off that process is very efficient. When we collect that steam, that wasted heat off the engine, we're running an efficient system that's more than 80% efficiency. One of the things I stress as much as I possibly can with this operation is the efficiency of how we take fuel and convert it into energy. In a combined heat and power plant, which East Campus is an example of, these types of plants are operating at more than 80% efficiency, and ours is one of those as well. And when you compare that to what the grid can do, when we buy electricity off the grid, which most of us do, that grid efficiency is about 30 to 35% efficiency. So we're more than double the efficiency here. That means that if we're double the efficiency, that means that we are also emitting half of the emissions.